Welcome back. I think in this session, I am going to take a look at CMake. Don't really know too much about it. But I get the general gist that it's a little bit more preferred over auto tools these days. And I know that I have messed with those way in the past, trying to build packages and never really come to terms with them. So I want to check out CMake. I'm going to be doing this with the same program that I have been working with all along, which is this little toy C program. Really is just a tutorial for myself, but it eventually will be a wizard, the kind of thing where you walk through and pick a bunch of choices and you can go forward and backward in those screens to eventually get a summary result of something. But right now, the thing that I want to do is take this little demo, which currently has this crappy little make makefile. This is a pattern that I've used for years now, generally with non-C tools. With non-C development, but I end up using Make as a task runner. And I almost always have a build run clean. And that was just how I started out this project. But I am actually just going, and then in the previous session, I went through and made sure that I was able to build with linked libraries, both in my Debian native system as well as when I'm in an X shell. And this time around, basically, I'm just going to go through a CMake tutorial. We'll see what we can find here. I haven't even looked for one, but it shouldn't be too bad. Let's find out CMake current version. So, looks like the latest release is 4.1. Yeah, 4.0.4.1. CMake tutorial. Are these the same thing or are they actually different links? But they're right on this. It looks like they're right on the CMake.org site. So, okay, so they are linking to different places. Is it just so this is, oh, it's actually, I see. We can change the version. Mastering CMake tutorial. Okay, what's the URL? Help book. So this is from a book, Mastering CMake, and then this is just a tutorial off the website. The book has to be older, and so maybe I'll come back to that, but we're going to start here. And we'll do it with the 401. Okay, so I think CMake has a CMake command, and I'm just going to guess that, that the package is named CMake in Debian. And it looks like it is. So we get CMake docs, CMake format, Ninja build. I know that now that I see that, I remember reading that CMake and Ninja are used together. I think Ninja is kind of a package manager. I don't know. I'll have to check that out. In which case, if it is, I won't need it because I'll be using, well, maybe I would on the Debian side, but on the Nix side, I wouldn't need it. Okay, we'll install that. And I'll assume also that CMake is going to be named CMake in Nix. So it's 3.2.5, typical Debian, very old. Oops. exit because the first thing I want to do is I don't really get the difference between I thought I got the difference, which is that that the native build inputs aren't part of the output. So like if that's true, then I would want these down here. And the only part of what I'm adding in would be the libraries so far, I think. I don't know if that's right or not. That's kind of a guess, and it's something I should experiment with later to determine. Nick shell. It'll download the stuff for CMake. So we get CMake, curl, expat, rhash. No, it's kind of an old version here too. So 3.3 versus 3.25. CMake, maybe the 4.0 is really recent. CMake releases 3.3.1. Oh yeah, so this is somewhere between those two, and then we get the 4.0. When did the 4.0 release? A date would be nice. CMake 4.0. So March 28th this year, so pretty darn new. So my guess is that, oh yes, I'm on the, if I look at my shell, my Nick shell, I'm actually tied to 2411, but Nick shell unstable. So I believe that this is all I need just to change that. So you can clearly do a lot more complex things, and this isn't even the right way to do it, I don't think, but it's a way to do it. So now I can do shell dot nix dot shell. Now this is gonna reinstall everything because they're gonna be different versions. So everything that's in that, all the packages that are in that nix shell. This will probably be a better way. Well, it's literally the example they give here. So we're seeing all the stuff get reinstalled. Core utils is a bunch, and all the pieces. So I think I'm going to use this format if I'm not already. If I remember right, I kind of hacked on it a little bit when I created it the first time. I don't understand overlays. I kind of get it's like doing things in layers, but Let's see. So, oh, no, my second line. So fetch tarball, import the tarball as packages. And so the only thing different is, and might as well make this line up with, right? So my take on this is that the Nix packages really are just a bunch of source code. They're the derivations for all the different packages. And so the output of, let me think this through. So I'm importing those. I actually can't read that. I don't know the language well enough. This, I think, is a struct, essentially, a map, where we're assigning config nothing and overlays nothing, and importing. I don't know. I really need to. I need to learn that. Let's just put it that way. But right now, and I know one of the big things here is the you output of make shell is going to be this whatever's in this packages. But I don't think we actually output anything when we do a shell, so that might be a little off too. Okay, so if I go back and do make shell, everything should be installed. And if I do CMake version 3316, okay, should be good to start a tutorial. Basic starting point. Where do I start with CMake? This step will provide an introduction to some of CMake's basic syntax, commands, and variables. Each exercise of the step will start with some background information, then a goal, and a list of helpful resources. Each file in the Files to Edit section is the step 1 directory. It contains one or more to do. Okay. Also note that each step in the tutorial builds on the next. The most basic CMake project is an executable built from a single source code. That's what we have. For a simple project like this, a CMake lists text file with 3 commands is all that's required. Okay, so the starting point is this. Although the upper and lower and mixed case commands are supported by CMake, lowercase commands are preferred and will be used throughout this tutorial. Any project's topmost CMake text must start by specifying a minimum CMake version using the CMake minimum required command. This established policy and blah, blah, blah. Okay, so we're going to have to specify this. They don't actually write it as a example, so we'll see. Okay, to start a project, okay, blah, blah, blah. The top of the project, you have to have that. To start a project, we use the project command to set the project name. This call is required with every project and should be called soon after CMake minimum required. Finally, the add executable command tells CMake to create an executable. Okay, pretty straightforward. So we're going to edit CMake text. The source code for the tutorial is CXX. Tutorial CXX is provided, blah, 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 directory, so you can, in the same, blah, 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 to do, build and run. Make directory, step 1 builds. Okay, so they're going to have us do this. To navigate to the build directory and use CMake to configure the project and generate a native build system. So it looks like they expect you then call the build system to actually compile and link the project, blah, blah, blah. So that's how to build and run. What I want to see at this point is the contents of the damn file because it helps to translate your words, their words, into next. Okay, getting started. This file does not. So you build tutorial help. Once to do 1 through to do 3 have been completed. Okay, so this is the kind of tutorial I really dislike. You should throw, this is what we're going to make out, show you the whole goddamn thing, and then walk through it. Because, okay, to do 1. Well, okay, so they are giving us the text. They're just hiding it so I can't see it initially, so. Whoa. I have a new keyboard, and I just have not been able to get used to the spacing in it. It's just a little bit off from my old one. Okay, so we're saying version 3.10 here. But what I'm going to do is I'm going to drop back out of here. I'm going to do CMake version, and it's 3.3.1 is what I have in. Oops. It's not happy. Okay, so CMake version is 3.2.5. So we're going to use 3.2.5.1 as my minimum. Oops. 3.2.5.1 is the minimum. And this is in that CMake text, 3.2.5.1. Okay. Project. It's going to be demo. So it's project tutorial. So it clearly looks like you can just put anything in there. And then the last thing, the last command is add executable. And the thing I wonder is, so I assume what we're doing is we're saying that this name up here is the first parameter and then the source code file. So okay. CMake has some special variables that are either created behind the scenes or have meaning to CMake when set by the project code. Many of these variables start with CMake underscore. Avoid this naming convention. Okay. 2 of these special user setting variables are CMake CXX standard and CMake okay, so it's intended for C and C++. So what I'm wondering is if there's a C version or if, okay. Looks like set property target, blah, 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 C standard. Target. And added in 3.2.1. So we would be able to use 17. And actually, I'm just going to leave that all out for now. let's go back. That was getting off base. So they cover those things for this CD step 1 build. CMake build is the command. Okay, CMake build directory. Yep, CMake build this directory. Let's exit out of Nick shell. We're more likely to have problems there. CMake could not load cache. Same usage. CMake path to source, path to existing build, path to does it we're going to move the makefile up out of this directory. The Nick shell shouldn't bother anything. I'm going to move source main to this level. CMake build could not load cache. Let's build. Okay, so build and run. Blah blah blah. CMake. So CMake. Okay, so we have to configure this project and then mean C back into source where it was looking for it. And then if I CMake this directory, it's done. And then if I CMake build, so what did it do? Okay, so it can't clean up after itself. I'll deal with that later. CMake -- build this directory. Okay, so undefined reference to YAML, blah, blah, blah. Okay, that makes sense. It doesn't know how to include libraries yet. So what we're going to do is we're going to, we'll comment all of that out. All right. And then do CMake build this directory. There we go. Where did it put it though? Right here. And it works. Okay. So, then it goes into specifying the C++ standard. Two of these are oh, I think that I just have to okay, so set property target. I think that it's going to look this way. I think that it wants me to specify the demo. Specify demo. I think that's it. Set property could not find target demo. Perhaps it has not yet been created. So I don't know what a target is for sure. I thought it was the project. So let's just search for that. That property could not find demo. Somebody will say, hey, bozo, you have to set XYZ. Okay, so the come on. I think this is that same one. Set property target. Blah blah blah. In my opinion, you should try out of source build with the following structure. Blah 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 blah. Zlib. Okay, so that's not going anywhere I want it to. Okay, so let's just go back to the tutorial. And here we have adding a library. Okay. Exercise 2. CMake has some special variables that are either blah 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 and set by the part. Many of these variables start with CMake. Avoid this naming scheme. 2 of these special user settable variables are CMake's CXX standard and CMake CXX standard required. These may be used together to specify a C++ standard to build the project. Add a feature that requires C++ 11. Target compile features. Let's start with some really basic stuff. CMake. How to specify the build output directory. Runtime output directory, CMake binary directory slash. Thanks for testing my code this morning. I ran my code previously, but I have commented out and wonder if there was a CMake set command. I'm guessing it like basically sets a environment variable kind of. Set variable value parent scope. Set. Okay. CMake runtime output directory ends up being. I want to just do a little experiment here and okay, so let's start with just bin. What will I get? CMake build this directory. Okay, that did what I wanted. RM demo. Let's get the makefile back so that I can. Okay, so it has that makefile. Which I mean, I guess. CMake build directory target clean. Okay. Um, CMake clean target. I'm really kind of not liking this, but I'll get used to it here. So, um, this is what I wanted somebody to, okay, this project statement, you should always list the languages. Listing the version is nice. Modern C, example version languages C. Um, so in this project, I, there we go. Does that. CMake build this directory. Seems to have done the thing. Okay, we're going to, so it defines a project, and then what they do is they add a library. All right, I'm going to have this one first still. Add a library, my example, my lib example. Simple lib C++. Okay, so let's require it again. CMake build this directory. Okay, no source is given. What was the first command that I ran? Configure or whatever, whatever configured the directory. Just CMake, right? So what I want to do is I want to So I want to clean this up. I'm going to create a clean shell. So let's um, okay. Want to get rid of that. Want to get rid of that. Want to get rid of that. Um, So I want to keep that one. Don't need to delete that. I want to keep that one. I want to keep that one. Okay, so if I make it executable, move clean to leave it to just set it as clean LSSH. Okay, so back to nothing but CMake lists. So I should be able to do CMake. No, that wasn't what we did. So something else was there. Build and run. One's to do, and then when completed, you're ready to run your first CMake make GUI, for example. I don't think CMake build dash could not load cache, right? And that's because it's missing. Okay, it has to be in this description before this step. Files to edit, getting started, build and run. Run the CMake executable or the CMake GUI to configure the project. So it's CMake. Okay. CMake areas, text, add library, no source YAML. Okay, that's fine. Vim readme. The command I just ran was CMake current directory, and that's followed by CMake build current directory. And what did I not? Okay, so cache text has to get deleted as well. That's not what I wanted to do. Okay, so clean, take a look. I have just the CMakes list text, get ignore, readme, shell, source. Okay, and so if I do what the readme says, which is CMake, and then, okay, let's go back and fix it. So CMake, let's so we're going to CMake this directory, then we'll just start with that. CMake this directory. Okay, configured everything. And what it found was blah, 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 blah. Checking for, I wonder why that's skipped. Probably because it's literally got the GNU compiler. I don't know. Detecting. And it is there. Detecting compiler features, done. Configuring, done. Generating, done. Build files have been written to this directory. And nothing is in the bin folder. So is that my clean that didn't do that right? No. So clean does blow up the, it was probably because it made the output folder. So let's try that again. CMake this directory. Yep, it made the output directory. And then CMake build this directory. And the YAML stuff blows up. It makes sense. So So again, comment out the YAML stuff. CMake build this directory, and then I can bin demo. Okay, so let's fix that so we don't get a capital letter there. First clean, then okay, the output name is just demo. The language is C. We've set the output directory. Now we want to add a library. Yeah, we're getting there. So getting something. So so down here, this number, adding a version number and configuring. Sometimes it may be useful to have a variable that's defined available source code. Configure file. Okay, so one way to accomplish this is by using a configured header file. We create an input file with one or more variables to replace. These variables have special syntax, which look like var, or var, and then use the configure file command. We could edit the version directly in the source code using this. Using this feature is preferred since it creates a single source of truth. Define the report the project's version number. Files to edit. So basically, what they're suggesting is I should have source demo.h, right? Oops, that's not at all what they're suggesting. So it's demo.h.in. Source demo.h.in, vim source demo.h.in, you split. I want the CMake file over here, and continue to edit from steps 1 to getting started. In this exercise, we start by adding a project version to the CMake in the CMake Slicks text. So, okay. Oh, they think that's the answer. Well, whatever, piss off. So this is pretty straightforward. We can set so we have the version set right here. Then we use the config file to copy the input file with the specified CMake variables in place. So configure file. Yeah. Oh, I see. So we set the project. We add where we want the executable. We set the output directory. We're going to say, hey, we want this file. And what we're going to do is we're going to write target include directories. Okay. Let's fix this part first. So this is demo h in, and demo h is what it creates. And I know that obviously over here we need some var name for it to substitute. Yeah, so we can define major and minor version number. That makes sense. What we want to change here is tutorial to demo. So we got demo version major, okay. And then what we want to do is, well, clearly over in the actual source code in main, what they're telling us to do here is to include our demo.h. And then finally, it's just going to spit it out and show it to us, but we need to define these values in the, is it just set that we use for these? I think it probably is. So what we end up writing is set demo version major 0, set minor to 1. Is it set demo version patch to 0? Okay, and so and then what they do here is we're just going to output one of them for good measure. So it's going to be why would it do it backwards? Oh, maybe it's something I don't know. Oh, it's major, minor, patch, and just so that I can tell them apart. Okay, give myself a quick little script to build so I don't have to type 3 words. Configure incomplete, makefile error at CMake text 14. Configure file. Okay, it's fatal error, no such file or directory. Include demo, that makes sense. Build files have been written too. Okay, so I'm missing a thing. Oh. Is that what I need to do? See, now a bunch of things could be going on. It could be CMake file error, blah, 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 C demo H does not exist. So it's looking for it. Oh. CP source demo. I want to copy that here. So now we have our C demo, or where's the demo? CP from source. Oh, there's our demo in. Demo version minor. So I totally botched that. Let's. Demo version patch. See, it all looks right over here. But if I look in the demo in H file, what did that? So it says demo minor. Oh, in print in the source code. E split. E source main. So, where did I? Oh wow, I put that in a weird place. I thought I was putting it here. Demo version major, demo version minor, and demo version patch. Okay. So if I go look, I would expect. Oops. To find in the source, I would expect to find demo H now, right? Yep. Okay, kind of a pretty literal translation here. So that's what I would expect from that. Okay, now the error was something about prompt undeclared first use in this function, 2318. Oh. Let's put this back for a second. I only want to take that line. And then there we go. Okay, so I'm starting to get there. So what's left over after I clean? RM, get rid of that demo. I wonder like how people organize it if they leave these like templates like the demo.h right at the top level. I guess you likely only have one. So that wouldn't be so bad. Okay. I probably should look at, there's a lot of different task runner programs other than Make, because I mean with this thing, so if I build, right, one of the things it does is it creates a makefile, and it's kind of an ugly one. But I should look through this really good at some point. But I'll learn more about CMake as I go along. I just need to get kind of a reasonable basic amount of functionality right now. And I think we're there, right? Oh no, we're missing the library part. Um, okay, so uh, oops, did it again. Okay, so we're not adding a library yet. Let's do these in. So this is where we're doing the C standard. Does that work? For the time being, I'm going to do CMake error, blah, 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 set property. Set property could not find target demo. I would guess that is because the target is now demo. Okay. That's interesting. On line 4, right? No. Set property to demo. CMake error on 17 and library. So let's make sure it builds here. And we should have, okay, so it's putting demo out here on the top. So let's add that to clean. If it exists, we want to remove demo and demo. Now let's get back to getting a bin folder. I had that working. And the way we did that was add executable, source main. This was it right here. It's happening after. Do they have to be in the other order? So I have a bin folder. Bin demo. Ah, that's interesting. My print don't work. Oh yeah, I'd have to have a print D and a print D and a print D. Oh, I'm probably kind of brute forcing this, right? So once I've done that, I can just make. Yep. Demo, bin demo. So let's do that. I'll probably have to figure out how to add that someday. Demo, bin demo. So I'm getting version 123, just as I expect. My name is Mike, and adios. Okay, so this is working good. The thing that we're missing is so we'll clean. Oh yeah, let's shut that up. Okay. Did I just do that? Cat clean, cat. Did I just duplicate the file? So they are the exact same contents. Okay. The part that's missing is Vim CMake. I am not setting up. Does this work? Error, set property. Could not find target demo. Okay, I don't know what that is. I'd like to set that, but first let's solve the library thing. Adding a library. To add a library, rather than placing it, blah, blah, blah. Once the library is created, it is connected to our executable target with target include directories and target link libraries. Okay, so files, getting started, build and run. So in this exercise, we'll add a library to our projects that contains our own implementation for computing, the square, blah, 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 whatever, whatever, whatever. I don't want, yeah. Okay, so it's going to be add library, name, type, exclude from all. I don't know what that is. Let's find out. Well, no sources given to target YAML. Sources. Well, what the fuck do sources look like? CMake library sources. Oh, so when they add a library, this is a default library that will match variable setting. Other common choices are static, shared, and module. Including header files. Here helps IDs, but is not required. Output libname matches. Making sure you link your targets with this command. It is also link libraries. CMake library libyaml. Option. Build shared libs. Build libyaml as a shared library. Offset blah. That wasn't what I was looking for. I want include directories, add libraries. Okay, so let's assume so no sources given. CMake library sources. Static. Okay, so first it builds. Second, let's let's make sure we have it turned back on. I mean, so that we're actually using it. So I want it to fail to build. Right? Yep. So fails to build. Now, let's come back here. So include system distro provided add executable target link libraries main subproject. I get the unless I'm misunderstanding this, they're treating these as like they're referenced that they're referenced that they're vendor that they're in a folder with that you have the source. Include past not working and shared library code. Dun, 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 dun. Target include directories. I don't want standard libraries. CMake. What CMake variable is used to set C++ standard libraries? Set CMake Xcode attribute clang XX. Dun, dun, CMake hello world example. No, we'll find it eventually, and it'll be something really stupid. Indicate which libraries to include during the link process. So what they're using here is target. That's such a honestly, that looks like that suggestion is broken, but I don't know. But what I want is probably just YAML. Cannot specify link libraries for target YAML, which is not built by this project. What the fuck? Something so simple and it's going to take me forever. CMake include distro provided libraries. System supplied. So there we go. There's the question. I'm new to C, except for C++. These files, now in my blah, blah, blah. Okay, so that's where they're at, but this won't compile, blah, blah, blah. Target link libraries, project name, pthread. Okay, so it looks like target link libraries. Target link libraries. Project name, YAML. There we be, nice and simple. I mean, whatever. Okay, now the last thing I want to go back and I want to take a look at this thing. So I was using that to set the standard, and I'm using that to set the output directory. But can I use this, set CMake runtime output directory? They're the same, aren't they? CMake runtime output directory to bin. Yeah, they're the same. Okay. So CMake setting the C standard. What it tells me is set property target. Can I do set property? Error, set property. Set property given invalid scope demo. Valid scopes are global directory target. Set property given invalid scope demo. Valid scopes are global directory target. Okay, so let's just. Everything worked, right? Okay, so it probably isn't going to work. That was too easy. I mean, not too easy, but probably won't work on the next side. So we got this working on the Debian side. So we can clean and we can build. CMake's list. So we got demo HN. I don't tree source. It's the only directory we have. But vim clean. I want to kill rmrf source demo.h. That's a generated file. So we have build, clean, CMake list, demo hn, readme, shell. So, and if I build, does the whole thing. And then if I demo, bin, demo, it runs. I just can't spell my own name. Okay, so let's do a clean and then do a nix shell. And then do a build. Ooh. And then do a, so we see a lot of differences here. Version 12 with a compiler, version 14. Um, that's interesting. The full link down. Okay. And if we run it, it works. And if we LDD bin demo, we get the what we expect. Okay. So so that was probably very poorly narrated by me, and uh, I need to learn a little better, like how people normally organize these packages that are CMake packages. But I think that that gets me most everything that I need for a while. Um, I mean, I can include libraries. I might have to come back and revisit this if I need to. Like if I decide, and I probably will decide to make my own libraries so that I can link them in a little bit easier for tests. I think so I can test libraries independently. We'll see. Again, it's been so long since I've done any kind of C development. I don't really know what exists for test frameworks that people use. So I'll have to investigate that. But I think I have the new normal for now. I'm sure I'm gonna complain about CMake later in the future when it can't find some library or header. But we'll see. Um, I'm sure. I'm sure over time I'll learn. It'll balance out. It'll be worth it in the end. So, uh, git status. Um, so we're adding the CMake. Before we do, let's take a good look at that. It's relatively clean. So those are all kind of grouped together. Um, yeah, I think that's fairly clean, right? Um, I think do that that way. Yeah, I that's gut feeling. That's kind of a clean way or a logical way to organize those things. So, so what do? We converted. Um, we converted the C code to use CMake. That was a bit of an adventure. Didn't complain too much. I think I only swore one time. So GitHub push git or git push GitHub main, and I guess in the next session, I mean, I kind of have a full working kind of little framework here. Uh, I could likely, I mean, the thing I should probably do is actually start to write this program now. I have, um, makes the most sense. Somewhere down the road, I'm going to do write a, do the next part to write a derivation for building this code. And then, um, because that becomes part of the delivery mechanism, right? If I want to, uh, one way to do this is if I build the derivation and publish it, and then um, on another system, I can just um, include that in the Nix environment, and I automatically get this program. And I want to experiment with that full loop. It's part of that delivering software thing. Anyway, I think rather than that, though, the next time, I think I'll probably just work on learning more C. So until the next boring coding session.